Okay, so you know how we're always like, searching for information online, right?
Yeah.
Like all the time.
Ah,
Imagine that. But instead of, just like matching keywords or whatever,
right.
the AI is actually like researching.
Whoa.
It's actually like formulating a plan,
Yeah.
deciding, like which sources are trustworthy,
Mm-hmm.
and even like knowing when to say, like, I
Okay.
can't find the answer to that.
That's pretty wild.
Right. It's pretty mind blowing.
It really is. I mean, it's a huge shift, I think. Yeah. For
Yeah.
so long, we've, thought of AI as like a very sophisticated search engine.
Right.
But this idea that an AI can actually conduct research,
Yeah.
almost like a, dedicated
Yeah.
human researcher,
Mm-hmm.
that's really a monumental step forward.
It is, and that's exactly what we're diving into today.
Awesome.
And you flagged this really compelling research,
Yeah.
this paper called DeepResearcher, Scaling Deep Research via Reinforcement Learning in Real-World Environments. And the thing that immediately caught my eye was the ambition here. They're
Mhm.
actually training AI to do this kind of in-depth research using
Mhm.
the live, unfiltered internet,
Right.
not just like some, tidy prepackaged data set.
Exactly. And that's really, the internet is such a,
Oh, yeah.
sprawling,
That's
ever-changing,
huge.
and often disorganized
Yeah.
repository of information
Right.
that trying to equip an AI to actually effectively navigate that
Uh-huh.
and extract knowledge from that,
Yeah.
it presents a completely different set of challenges
Absolutely.
than, working within the controlled environment
Oh,
of
yeah.
like a specific document collection or
Yeah.
something.
Right.
It's a whole different ballgame.
Totally. Okay, so if we like boil it down,
Okay.
our mission today is to understand how Deep Researcher works.
Okay.
How are these large language models,
Yeah.
and LLMs as they're called,
Yep.
being taught to become these autonomous researchers
Okay.
using reinforcement learning in these dynamic web environments? And then like what kind of surprising capabilities are emerging
Yeah.
as a result of this approach?
That's a great way to put it.
Right.
I think we're
Yeah.
really witnessing the birth of like a new kind of AI research agent.
Yeah, absolutely. Okay, so before we get into the specifics of how Deep Researcher does its thing,
Okay.
let's take a step back.
Okay.
Why is this such a big deal?
Yeah.
What are the limitations with how LLMs currently approach these research tasks?
Yeah, that's a crucial place to start.
Yeah.
So I think one of the most common methods right now
Okay.
for leveraging LLMs in research is what's called prompt engineering,
Okay.
which is essentially where humans kind of meticulously craft
Yeah.
very specific instructions or prompts
Yep.
to guide the LLM's search and reasoning.
Okay.
But the problem with these prompts is they can be very brittle.
Okay.
Like even a minor change in the question
Yeah.
or the kind of online landscape can completely derail the process.
Right. So it's like you almost need like the exact magic words
Yes,
to
exactly.
get the answer that you're looking for.
Yes.
And if you're off by even a little bit,
Yeah.
it just falls apart.
It breaks down completely.
Yeah.
And, another approach that people have taken is what's called retrieval augmented generation,
Right.
or RAG.
Okay, RAG.
So with RAG, the LLM searches
Yeah.
within a kind of predefined set of documents.
Okay.
So you can think of it like a closed digital library.
Okay, so it's pulling from like a specific set of things.
Exactly. It's pulling out relevant snippets
Yeah.
from that collection
Okay.
and using those to kind of construct an answer.
And what's the like fundamental constraint with that?
Well, the core limitation there
Yeah.
is that it assumes that all the necessary information
Okay.
already exists within that specific library,
Oh, I see.
right? So like imagine trying to research
Okay.
a groundbreaking new medical treatment or like a rapidly unfolding geopolitical crisis.
Yeah.
But you can only use like a set of research papers from 5 years ago.
Right.
You're inevitably going to miss crucial up-to-date information.
Yeah. It's like trying to predict tomorrow's weather
Yes, exactly.
using only historical data from like a single month.
Right.
You're going to be way off.
Exactly.
Yeah.
Yeah, you need that current real-time information.
Right.
And, there have been some attempts to apply reinforcement learning
Okay.
to information retrieval tasks,
Okay.
but these have largely focused on
Yeah.
those kind of static local collections of text rather than the live, constantly evolving web.
Okay, so we've got the fragility of prompt engineering.
Yeah.
We've got Raj's reliance on this fixed body of knowledge
Yeah.
that sets the stage for Deep Researcher.
Oh,
But what is their approach? Like, what's fundamentally different?
So the central breakthrough with DeepResearcher is that
Okay.
it's the very first framework
Okay.
to train LLMs end to end
Okay.
for these complex research tasks
Uh-huh.
using actual real-world web search.
That's the key difference.
End-to-end training on the real-world web.
Exactly.
That sounds so much more complex
It is.
than what we were just talking about.
It really increases the complexity
Yeah.
by training these AI agents
Okay.
directly within what the researchers call
Yeah.
the noisy, unstructured, and dynamic nature of the open web.
Right.
They're directly confronting
Yeah.
the limitations of our ag.
Okay.
The AI isn't confined to this curated data set. It has to learn to navigate and interpret
Yeah.
the internet as it truly exists.
So it's learning to navigate like a vast, uncharted ocean
Exactly.
instead of just like paddling around in a swimming pool.
That's a great analogy.
Right.
Yeah.
Yeah. And to do that, you need some serious tools.
Absolutely.
Yeah.
And to manage this immense complexity,
Okay.
they've designed a multi-agent architecture.
Okay. A multi-agent architecture.
Now, just imagine trying to read and digest
Yeah.
every single web page.
Okay. That pops up in a set of search results.
That would be impossible.
It would be overwhelming.
So just the volume alone,
Yeah.
and then all the different ways that different websites
Would you-
present information.
It would be a nightmare.
You would just get so lost.
Exactly. And that's where this multi-agent system comes in.
Okay.
So they have these specialized browsing agents
Okay, browsing agents.
that are specifically engineered to extract the relevant information
Okay.
from a wide array of web page structures.
Interesting.
So it's effectively tackling this huge technical challenge
Yeah.
of dealing with all these different
All the different formats and layouts.
website formatting and layouts. Exactly.
Yeah. Okay, so we've got end-to-end training on the real-world environment and
Yes.
these browsing agents.
Mm.
What were some of the key technical innovations that they had to make this possible?
Yeah, so there were several crucial elements.
Okay.
The first is what they call scaling RL for deep research.
Okay, scaling RL for deep research.
Yeah. So, in traditional reinforcement learning for this kind of task,
Okay.
you might predefine specific steps
Okay.
or actions that the AI should take.
Uh-huh.
But DeepResearcher actually scales RL
Okay.
directly based on the success of the research endeavor
I see.
without these pre-scripted steps.
So it's not just following like a protocol, it's actually like
It's
starting to research.
It's learning what strategies are most effective
Okay.
through trial and error
Oh.
on the live web.
So it's like learning to ride a bike.
Exactly.
You don't
Like,
follow a set of instructions.
you just do it.
You just gotta do it.
And you adjust based on
Why?
work.
It's on your experience.
Exactly.
Cool.
And then there's the real world environment aspect,
Right.
which we've touched on a bit.
Yeah.
But it's important to emphasize like
Okay.
the sheer difficulty of operating on the internet.
Yeah.
It's full of irrelevant data,
Right.
poorly written content,
Yeah.
even deliberate misinformation.
Oh, gosh.
So DeepResearcher had to develop these sophisticated mechanisms
Yeah.
for filtering and evaluating information
Right.
that it encounters.
Like, how do you even begin to train an AI to do that?
It's a great question.
Yeah.
And that's really a key part of what emerges through this reinforcement learning process.
Okay.
So the AI receives positive feedback
Okay.
or a reward
Yeah.
when it finds information that helps answer the research question accurately,
Good.
and it gets negative feedback, a penalty,
Mm-hmm.
when it gets sidetracked
Right.
by irrelevant or misleading content.
So it's like,
So over time, it learns
Yeah.
to identify more trustworthy sources
got it.
and more efficient search strategies.
So it's like training a dog, right?
Kinda.
Yeah. It's like you give it a treat when it does the right thing,
Well,
and you know,
correct it.
you tell it no when it does the wrong thing.
Yeah, and then, another key element here is
Okay.
what they call end-to-end training,
End-to-end training.
which, as we mentioned, means that the AI learns
Yeah.
its own research strategies from the ground up.
Okay.
It's not just adhering to human-designed workflows.
So they set the objective, but the AI figures out how to get there.
Exactly. It's learning the whole pipeline,
Wow.
from initial query to final answer.
That's incredible.
And then they also had to address what they
Yeah.
call implementation challenges.
Implementation challenges, what does that mean?
So think about it this way.
Okay.
Constantly sending out search queries
Yeah.
and crawling websites.
Okay.
You can quickly run into API usage limits.
Right?
You can get slowed down by network latency
Uh-huh.
and even trigger anti-crawling measures.
Oh, right, because websites are not designed to have AI constantly scraping their information.
Exactly. They don't want that.
Right.
So deep researchers actually implemented a bunch of clever solutions.
Like what?
So things like a distributed network of servers
Okay.
to handle the volume of requests,
Uh-huh.
a system that automatically retries failed attempts, and a caching strategy
Yay.
to avoid performing the same searches repeatedly.
Smart.
It was a significant engineering feat
I bet.
just to keep the system running smoothly.
Yeah. Okay, and then finally, let's go back to the multi-agent framework.
Okay.
And these browsing agents, they're crucial here.
They are.
And unlike RAG,
Yeah.
which is usually working with these small snippets of text,
Yeah.
these agents are actually designed to process entire web pages
Yes.
sequentially.
Good.
So it's not just getting like a sentence or two out of context. It's more like having a research assistant, like read through the relevant sections of a website and understand the full picture.
That's an excellent analogy.
Right.
These agents are much more thorough
Okay.
and context aware.
Okay, so they've built this crazy sophisticated system.
They have.
What kind of results are they actually seeing?
Right.
Is it actually performing well?
Well, the quantitative results are impressive. So the paper shows that deep researchers achieved substantial improvements,
Okay.
up to 28.9 percentage points better
Wow.
than methods that rely solely on prompt engineering,
Okay.
and 7.2 points better
Correct.
than RG-based reinforcement learning agents.
Wow. 7 points is huge.
It is, especially in a complex task like this.
Yeah.
So figure 1 in the paper actually has a nice visual representation of these gains across 7 different data sets.
Okay, so these are not just like incremental gains.
Yeah,
This is like
it's step change.
a step change.
Yeah.
Okay.
But what's, I think, even more compelling
Yeah.
is that they observed what they call
Okay.
emergent cognitive behaviors.
Emergent cognitive behaviors. What does that mean?
That arose from this end-to-end reinforcement learning training
Okay.
in real-world environments.
Yeah.
These weren't explicitly programmed into the system.
Okay.
They kind of just appear
As a result of the training.
as a result of the training process. Exactly.
That's wild.
Yeah, it's really interesting.
Right. Okay, so what kind of unexpected abilities are we talking about?
So one of the key ones is planning.
Planning. Okay.
So DeepResearcher was able to
Yeah.
formulate a sequence of steps
Okay.
to address a research question,
Uh-huh.
and importantly, to dynamically adjust those steps as it goes.
Okay.
So figure 2 in the paper kind of illustrates this.
Okay.
And they give this example
Yeah.
in figure 5,
Okay.
where the AI is faced with this question
Yeah.
about a famous bridge
Okay.
in the birthplace of the composer of Gloria in D major.
Okay.
And it breaks down this problem
Yeah.
into these logical subtasks.
Okay.
Right? So first identify the composer,
Okay.
then determine their birthplace,
Uh-huh.
and then search for a famous bridge in that city.
Okay.
And this is all stuff it learned to do on its own.
Wow, that's exactly how a human researcher would approach it.
That's right.
You'd be like, okay, who composed this piece?
Yeah.
Where were they born?
Exactly.
Is there a famous bridge there?
That's right.
Yeah.
It learned to break it down.
That's incredible that it just like came up with that on its own.
And that's just one example.
Okay, what else?
Another one is what they call cross-validation.
Cross-validation.
So the AI learned to actually verify information it found from multiple independent sources.
So it doesn't just accept the first thing that it sees.
Exactly.
It's like checking its work.
Yes, exactly.
That's cool.
It's like a fact checker.
Okay.
So even if it finds a potential answer early on,
Yeah.
it doesn't just accept it at face value.
Okay.
It continues to search for corroborating evidence.
Smart.
And that, significantly enhances the reliability of its research.
Right, because you can't just trust the first thing that you see on the internet.
Exactly.
Okay, cool. What else?
So another interesting one is self-reflection,
Self-reflection.
which is shown in figure 6.
Okay.
DeepResearcher actually showed this ability
Yeah.
to recognize when information it was finding
Okay.
was not directly relevant to the question, and then refine its search queries to get back on track.
So it's like realizing that it's going down a rabbit hole
Exactly.
and being like, okay, I need to course correct.
That's right. And they have this example in the paper
Okay.
about finding the burial place of Jedifor's father.
Okay.
And it initially goes down this kind of tangential line of inquiry, but then it adjusts its approach.
To focus on the right person.
Exactly. And that kind of meta-awareness
Yeah.
is really something we haven't seen in these systems before.
That's really cool. Okay. And what else?
And then finally, there's honesty,
Honest.
which is also illustrated in figure 6.
Okay.
The model can actually admit
Oh, wow.
when it cannot find a conclusive answer.
So it's not just making stuff up.
No.
It's actually like,
They give this example about oil production in Luanda,
okay.
and it finds information about Angola's oil production.
Yeah.
But it can't find the specific figure for Luanda.
Right.
And instead of just like guessing or giving an incomplete answer, it says, I cannot find that specific information.
Wow.
Which for someone like you who values thorough and accurate knowledge is super important.
It is, because I need to be able to trust that this AI is not just like making things up.
Exactly. You need to know when it doesn't know something.
Right.
And these emergent behaviors collectively demonstrate that this training in a real-world environment using reinforcement learning doesn't just optimize performance. It actually fosters a more nuanced and sophisticated approach to research.
Almost human-like, you're saying.
Almost human-like, exactly.
Okay, so this is super promising.
It is.
Now, you mentioned that they trained it using existing open domain question answering data sets.
Yes.
How did they prevent the AI from just like already knowing the answers?
That's a great question, and that's a real problem.
Yeah.
Because LLMs are trained on this massive amount of text.
Yeah.
And this pre-training data could actually include the answers to questions found in these evaluation data sets.
Right. So then it's not actually researching, it's just remembering.
Exactly. And that's what they call data contamination.
Data contamination. Okay.
If the model already knows the answer, it's not really learning to research it.
It's just remembering something it already saw.
Exactly. It's just recalling information.
Okay.
So to prevent this, they used this rigorous two-stage filtering process.
Okay, two-stage filtering process. Break it down for me.
All right, so the first stage was what they call low-quality question filtering.
Low-quality question filtering.
This involved excluding questions that were time-sensitive.
Okay, so like...
Who is the current president?
Yeah, that would change all the time.
Exactly. Or questions that were highly subjective.
Right, like what's the best type of music?
Exactly. Or potentially harmful.
Okay.
And they actually used another LLM.
Oh, wow.
Called DeepSeek R1 to help identify.
So they used AI to help train their AI.
That's right. That's pretty cool.
To make sure the quality of the data was good.
Yeah.
And then the second stage was contamination detection.
Contamination detection.
So for each question that passed the first filter, they randomly sampled 10 responses from the base model without allowing it to access any search capabilities. And if the model could answer the question correctly, even once out of those 10 attempts, that question was excluded from the training data.
I see.
So this is what they call the pass at 10 check.
At
10.
And
it ensured that they were really training it on questions it didn't already know the answer to.
That makes sense.
Yeah. So after this whole process, they ended up with about 80,000 question-answer pairs.
80,000.
And they focused on including a lot, what they call multi-hop questions.
Multi-hop questions. What are those?
So those are questions that require...
synthesizing information from multiple different sources.
To
get the answer.
So it's not just like a simple fact.
No, it's really
more complex.
It's more complex. You need to pull from different places.
So you're really pushing the AI to actually do this research.
Exactly. And to develop those deeper reasoning skills.
Okay, now they need to evaluate how well it actually does.
They do.
So what were the benchmarks that they used?
So they used what are called evaluation benchmarks.
And
they tested DeepResearcher on what are called in-domain data sets.
In-domain.
Which are similar to the data it was trained on. So things like natural questions. Trivia QA. Hot Pot QA. And 2Wiki.
2Wiki.
And they also tested it on out-of-domain data sets.
Out-of-domain, which are different.
So it's like, how well can it generalize to new information?
Yeah, because you don't want an AI that can only answer questions.
Right. You want it to be able to apply this. You want it to be flexible.
To new stuff.
Exactly.
Yeah.
So these out-of-domain data sets included things like music, Bamboogle, and PopQA.
PopQA.
And to measure performance. They used a couple different evaluation metrics. So one was the standard F1 score.
That's one score.
Which measures the overlap between the AI's answer and the correct answer. And then they also used what's called model-based evaluation, or MBE.
MBE, model-based evaluation.
Where they essentially use another advanced language model.
Oh, wow.
Called GPT-4o Mini.
GPT-4o Mini.
To act as an independent judge.
So it's like a second opinion from another really smart AI.
Exactly.
That's cool.
And they note that the MBE metric is often more reliable. Because it can consider nuances beyond just simple text overlap.
So what were the key findings that emerged?
Well, the results,
Yeah.
which are detailed in tables 1 and 2 in the paper, are pretty interesting.
Okay.
So DeepResearcher consistently outperformed the other methods on these in-domain data sets when using this MBE metric. And it's important to note that there's another system called Search R1 Base.
Search is R1 Base.
That achieved kind of comparable results on some data sets. But it was trained and evaluated in a much more limited environment. It had access to a specific curated Wikipedia corpus.
So it was like spoon-fed the information in a way.
Kind of. Yeah.
And DeepResearcher had to find it.
DeepResearcher had to navigate the whole internet to find this information.
Right. So even if the answer was on Wikipedia, DeepResearcher still had to find it.
It had to go and get it.
Out of the entire internet.
Exactly.
That's way more impressive.
And even more impressively, DeepResearcher was really good on those novel out-of-domain data sets.
Right.
Which really suggests that it wasn't just memorizing patterns. It was actually learning transferable research skills.
He was learning how to do research.
Exactly.
That's what we want.
That's what you want.
You don't want it to just memorize stuff.
Exactly.
Okay, cool.
And the results on the Bamboogle data set
Bamboogle
were particularly interesting.
Okay, why?
Because Bamboogle questions often require knowledge that's beyond what's on Wikipedia.
Oh, interesting.
So DeepResearcher did much better than other methods on this benchmark.
Got it.
And even when they tested another system called R1 Searcher.
R1 Searcher.
Which was trained on a local R, but allowed to search the web.
During evaluation.
DeepResearcher still performed better.
Wow.
So just having access to the internet isn't enough.
It's got to know what to do with it.
It has to know how to use it.
That's really cool.
And the paper also includes this analysis of the training dynamics. Which are shown in figures 4 and 7. And these figures show that DeepResearcher's performance just kept improving. As it underwent this reinforcement learning.
So it didn't plateau.
No, it just kept getting better.
That's what we want.
And it also engaged in more reasoning steps when it was given more complex questions.
So it was actually like thinking harder about it.
It was putting in the effort.
That's really cool. Okay, so we've covered a lot.
We have.
If you had to boil this all down to like the one key message, what would you say is the most important takeaway?
I think the main takeaway is that DeepResearcher is a really big shift in AI research capabilities. By scaling reinforcement learning to the real-world web, they've unlocked this emergent intelligence that goes way beyond just simple information retrieval.
Right. So it's not just about finding information.
No, it's about understanding it, synthesizing it, and even critically evaluating it.